Now, polynomials don't have to be just one variable. Sometimes we'll see polynomials in several variables. An example from some of our industries in our construction industry models the amount of board feet in a particular length of wood or a tree. And it's modeled by this particular expression up here where x is the diameter of the tree in inches and y is the length of the cut. And based on that, this expression up here will determine the number of board feet for that particular tree. Like my tree? I know, I tried to do the best I could. So let's explore through the next couple of sessions of how to deal with polynomials in several variables. So let's begin by looking at a variable, sorry, not variable, but let's look at this expression, this polynomial in several variables, and we want to evaluate it when x equals a -2 and y equals a 3. So what do we mean by that? Well, let's go ahead and just kind of color code things just to get us off and going. Where x in this particular case, we described already, x equals a -2 and y equals a 3. So what we'll do is we'll take those values and we'll substitute them on in. So I have a 2, x squared, this becomes a -2 squared, times a y, which is a 3. X, again, just everywhere I see an x, I put the value in. -2 times a y squared plus 7 times the x, which is a -2, minus a 3. -2 squared is a 4, so 2 times 4 times 3. 2 times 4 is 12. 12 times 3, is that what it is? 6 times 4 is a 24. Plus a -2 times a 3 squared gives me a -18. Plus a -14, plus a -3. Add up all those terms. 18 and 14 give me a -32, -35, 24 plus a -35. Add those together, it gives me a -11. So this polynomial in several variables, evaluated at -2 and 3 for x and y, just simply evaluates to a -11.